Hello, everyone, and welcome to the Physics 121 concept review on interpreting an acceleration graph. My name is Nathan Martin, and I work for the tutoring centers at ASU. So, this problem, we're essentially tasked to use the graphs below to determine the final velocity and displacement of the particle. So, we're also assuming the initial velocity and position are 0. So this graph on the left, this is the acceleration graph. So this is the acceleration as a function of time, and the x-axis is the time. Okay, so let's look at the left graph first. So looking at this, I see that my acceleration, right, it's constant, right? It's a constant 2 until it reaches time as 3 seconds. And at 3 seconds, it's now equal to -1. So if I want to find the velocity, right, I just have to remember that the velocity is equal to the integral of the acceleration function, right? Remember, acceleration is the rate of change of the velocity with respect to time. So the inverse operation, i.e. the velocity function, is now the integral, right? The integral of the acceleration function. So what does the integral do? What does that operation do? It essentially just finds the area under a curve, right? So all we're doing is finding the area under this curve. So let's just draw that out. So it's this area, right? We have that area, but we also have this negative area. See, that's below the t-axis. That's a negative area. So my final velocity is equal to the acceleration, I'll call this at state 1 and at state 2. So the acceleration at 1 minus the acceleration at 2. What's the acceleration at 1? Well, that's not too bad, right? It's just a rectangle. We don't have to use calculus. We can just use our intuition of geometry, right? What's the area of a rectangle? Well, the area of this rectangle is just base times height, right? So what's the base? The base is 3, right? And what's the height? Well, the height is just 2, right? So the area of the first region is just 2 times 3. Minus, what's the area of that second region? Well, the base, that base right there is just 1 unit. And what's the height? Well, it's also just 1 unit. You would say to yourself, oh, isn't that negative? In the y direction, you're going down, so therefore the length is negative. I'm not even gonna bother with that because I know based on my intuition that I'm just subtracting these areas regardless. So I'm just gonna find it as a positive number. So it's 1 times 1. So my velocity, right, my final velocity is equal to 6 minus 1. Again, I shouldn't be calling this v of t, so to say, because we're finding the final velocity, but whatever, we'll keep with it. So the final velocity is equal to 5 meters per second. Or whatever units we were in, right? So that's the final velocity. Okay, so now let's look at this graph on the right. So this graph is the velocity as a function of time, and the x-axis is the time, okay? So this graph in red over here, that's the velocity graph, okay? So if I want to find the displacement, well, that's just the integral of the velocity curve, right? And integral, that's just a fancy way of saying area under the curve, right? So I have to find the area under this curve. So I'm going to kind of break it up into a couple shapes. right? Because I don't really want to use calculus. Mainly because I don't know the functions of these curves. I mean, I guess they're just lines, so I could create the functions on my own, but that's just more work for me. So I'm just going to look at this in terms of geometry, okay? So I have this region, right? That's the first region. I'll call it region 1. I also have this region here, region 2, and then I have region 3 right here. Well, region 1, that's just a triangle, right? So what's the area of a triangle? Well, it's 1/2 the base times the height, right? 1/2. What's the base? Well, I can just look at this thing, right? The base is 3 units, right? Base is 3. What's the height? Well, I can just look at it, right? The height is 6. And then I want to add, I should have clarified. So the displacement is A1 plus A2 plus A3, right? A1 being that that triangle, A2 being another triangle. So what's that little triangle? Well, that little triangle, right? 1/2 the base times the height. The base is, if I look at that, it's 1 unit. The height is also 1 unit. And then what's that area of that rectangle of region 3? Well, the base is 1 unit. And what's the height? The height is 5 units. So the displacement is equal to 1/2 3 times 6. So that is 9 plus 1/2 times 1, 1/2 plus 5. So the final displacement is equal to, if I can do this calculation, so 9 plus 5 is 14, plus 1/2 is just 14.5, right? So 14.5 meters. Awesome. So moral of the story here, velocity is the area under the acceleration curve, right? Because it's just the integral of the acceleration function. And then displacement is just the area under the curve of the velocity function. I also kind of want to point out these two graphs. If see that red graph on the right side of the screen, the velocity graph, that is the exact velocity graph of the acceleration graph from that blue function to the left. So if you really wanted to double check, you can find the velocity at the end time. So the velocity at what, 4 seconds, right? The velocity at 4 seconds of this curve right here. If I just look at that, right, that'd be that point there. So that's equal to 5. And well, look at that. The velocity at that is the exact same as that area under that curve for that acceleration function. So that kind of double checks with our intuition, right? Cool. So let's clear that up. If you want more information on tutoring, such as, you know, when we're open, the locations at which we're open, any review sessions we're holding, all those free resources that are available to you, visit our website at tutoring.asu.edu. And then if you want more information or you want to watch more of these concept videos, just go to that link there. Right. Thank you all for listening, and we'll see you in the next video.